Welcome to Quantum. I'm very pleased to announce that the second edition of my book, Lectures on General Relativity, Cosmology, and Quantum Black Holes, is now published by IOP Publishing. This expanded edition presents a layered journey from Einstein's gravity to the frontiers of quantum black holes and holography. It brings together a broad yet focused journey through modern gravitational physics, from Einstein's theory to the quantum frontier. Chapter 1 introduces the essentials of general relativity, the equivalence principle, space-time geometry, curvature, and Einstein's field equations. This chapter lays the mathematical and physical foundation for everything that follows. Chapter 2 explores classical black holes, Schwarzschild, Reissner-Nordström, Kerr, and Kerr-Newman solutions, together with their horizons, causal structures, and thermodynamic properties. Chapter 3 turns to cosmology, presenting the expanding universe, Hubble's law, redshift, cosmological distances, and the Friedmann equations that govern large-scale evolution. Chapter 4 develops the theory of inflation and cosmological perturbations, addressing the horizon and flatness problems and explaining how quantum fluctuations gave rise to cosmic structure. Chapter 5 introduces quantum field theory on curved spacetimes, examines the cosmological constant problem and vacuum energy, and outlines Horava-Lifshitz gravity as a potential quantum gravity framework. Chapter 6 derives Hawking radiation and the Unruh effect from first principles and examines black hole thermodynamics, entanglement entropy, and the deep paradox of information loss. Chapter 7 presents modern resolutions of the information paradox using holography and the ADS-CFT correspondence, including quantum extremal surfaces, the island conjecture, and replica wormholes. Chapter 8 outlines two distinct paths to quantum gravity, loop quantum gravity and the BFSS matrix model, offering radically different visions for unifying spacetime and quantum theory. In addition to its broad pedagogical scope, the book offers a self-contained and conceptually unified treatment of black holes, structured in three major stages. Stage 1, Classical Black Holes. Chapter 2. The first layer builds on the essential tools of general relativity, Chapter 1, to describe black holes as solutions to Einstein's equations. Topics include space-time geometry, horizons, and processes like free fall and energy extraction via the Penrose process. Stage 2, the information loss problem, Chapter 6. The second layer introduces quantum effects. Through Hawking radiation, the Unruh effect, and entanglement entropy, we examine the paradox of black hole evaporation and the tension it introduces between general relativity and quantum mechanics. Stage 3, Quantum resolution via gauge gravity duality, Chapter 7. The final layer proposes a resolution based on the ADS2-CFT1 correspondence. It incorporates advanced ideas like the island conjecture, quantum extremal surfaces, and replica wormholes, leading to a consistent and unitary page curve, realizing explicitly the ER equals EPR paradigm. Together, these three parts form a layered and coherent narrative, guiding the reader from classical spacetime to the frontier of quantum gravity.